Welcome to this class. In this class, we are going to solve some problems on the hydrostatics. So let's begin right away. So we have the problem number one is find the pressure at A and B. Okay, these are the 2 points A and B in a tank. The water is stationary in this tank. All right. Actually, there are two materials from 0 to 5.8 meters height. There is water. All right, and above this is some unknown fluid which has a unit weight of 8 kilonewton per meter cube. We don't know what fluid is this, but we know the unit weight of that fluid, and the unit weight of this unknown and the height of this unknown fluid is 3.2 meter. We have to find the pressure at A and B, right? So let's solve this. Let's find first pressure at A. Okay, then it will be easy to find the pressure at B, because pressure at B will be due to this height 5.8 of water plus the pressure at A point, right? So let's first find pressure at A. Pressure at A, we know pressure is given as pressure at A is equal to unit weight of water, sorry, unit weight of the unknown fluid multiplied by its height, right? Now here the unit weight is 8, right, kilonewton per meter cube, and the height is 3.2 meters, right? When we solve this on the calculator, what we get? 25.6 kilonewton per meter square, or 25.6 Pascal, right? Because 1 kilonewton per meter square is equal to 1 Pascal. All right, now let's find the pressure at B. Pressure at B. Now we know the pressure at B point is equal to, due to this height 5.8, which is equal to rho g h plus due to the pressure at A, right? Plus pressure at A. Now we know it's water, right? So the density is 1000 kilonewton per meter cube. Sorry, it is 1000 kg per meter cube. G is, we know, acceleration due to gravity, which is 9.81 meter per second square, and H here is 5.8 meters. So we get pressure at B is equal to 1000 multiplied by 9.81 multiplied by 5.8, right? And plus the pressure at A, right? What is the pressure at A? Is 25.6 multiplied by 10 to the power 3, right? Because here we have in kilos. So when we use the calculator, we get pressure at B is approximately equal to 82.5 kilonewton per meter square, right? So that's the answers. Let's continue the another problem. Now the problem is the gauge pressure in a fluid is 188 mm of mercury, and the atmospheric pressure there is 95.7 kilopascal, right? This is the atmospheric. What is the absolute pressure of the fluid? Let's solve. We know this absolute pressure, P absolute, is equal to P gauge plus P atmospheric, right? Now P gauge, the gauge pressure in a fluid is 188 mm of mercury. Now this is in terms of the head, right? Mm of mercury, millimeters of mercury, because it's the length, so it means the pressure is given in terms of the head, right? Head is like we know, like this is P gauge, we know it is rho g h, right? Now this h is the head and this is 188 mm of mercury. So let's write here what we get. We will get P gauge is equal to density of mercury is what? G times the density of water, right? Because the specific gravity of, when you multiply the specific gravity of the mercury with the water, you get the specific you get the density of the mercury, right? Multiplied by G multiplied by H is what? 188 mm, right? Which is 0.188 meters, right? So what is specific gravity of mercury? It is 13.6 and density of water is 1000 and G is 9.81 and we have 0.188. Okay, now when you will use a calculator, what you get? 13.6 multiplied by 1000 multiplied by 9.81 multiplied by 0.188, you get 25082.2 Newton per meter square, right? Because we have used all these in SI units, so the pressure will be in SI units too, that is Newton per meter square. The gauge pressure in fluid is 188 mm of mercury. Okay, now we find the gauge pressure. Now the atmospheric pressure is how much? 95.7 kilopascal. It is 95.7 multiplied by 10 to power 3 pascals, right? Newton per meter square. Now when you add up these two values, okay, so what we get? We get P absolute is equal to 25082.2 plus 95.7 into 10 to power 3. Okay, now let me use a calculator. I get P absolute is equal to 120,782.2 Newton per meter square or pascals, right? Sorry, I wrote here is 1 kilopascal, okay? Because here is some mistake. Let me erase this. It is 1 Newton per meter square is 1 pascal, okay? So therefore it is kilopascal. Kilo kPa, kilopascal, right? Here we go, we find the absolute pressure for this problem too. Now let's move on. Problem number 3. Now what's asked? Find pressure heads at A, B and C. Okay, we have this A, B and C points. We have to find the pressure heads, but we don't know what these fluids are. Maybe let me write what type of fluid is. Now this one, C to B, this is its specific gravity, G is equal to 1.6. okay, now this one is water, and here the specific gravity is 0.7, and this one is air. Okay, find the pressure heads. Remember this heads, right? So we have to find the h. The P is equal to rho gh. We have to find the h of each. So let's begin with what? Pressure at A, right? Now let me change the color. Now pressure at pressure head at A. Now we know pressure at A is equal to rho gh. Let us call this as h1. Let me call this as h2, and let me call this as h3. So the pressure at A will be what? Due to h1, right? h1, but there is another pressure too which is acting above A, okay, and which is minus, negative, means this is vacuum pressure. And remember, we have to consider the sign too, okay? If it's negative, we have to use as it is, okay? So plus minus 17.1 multiplied by 10 to the power 3 pascals, right? Because here is kilo, so it is 10 to the power 3. Okay, we have to find this h1, right? Because we have to find the pressure head. Head is this h1. How it is going to be? Basically, we have to find the head, okay? It will be h, but be careful, it will not be h1, okay? Because there is another fluid, actually it is air acting above A, okay? So this h1 will modify. We have to find the h. If there was no air above this point, I mean if there was nothing here, no air, then head would have been at A, would have been h1, right? But there is another fluid, so it won't be h1, it will be something else. So let's first calculate the pressure at A. Pressure at A is now density. Density of this material is what? G times density of water. That's how we find density of any material in terms of density of water and specific gravity. Multiplied by G multiplied by H1 is 3, right? This is 3 meters. Alright. And here it will be plus minus is minus 17.1 multiplied by 10 to the power 3. Okay. So now G is 0.7, right? Here is 0.7. 0.7, density of water is approximately 1000, multiplied by G is 9.81, and here we have 3, and then we have 17.1 10 to the power 3. Okay, now let's use a calculator to find the pressure at A. I found pressure at A to be 3501 pascals. Okay, now this is the pressure at A. Now we know Pressure at A, pressure at A is rho G H at A, right? Because we know the formula, pressure is rho G H, but H is what? Head at the A is equal to 3501, right? Now, this rho is density of this material, right? Which is G is equal to 0.7. So it is G times density of water multiplied by G head at A is equal to 3501. Now G is what? 0.7, right? 0.7 into 1000 into 9.81 multiplied by head at A. We don't know head at A is equal to 3501, right? Now here we can find the head at A from this relation, right? We can find head at A. How? Head at A will be equal to 3501 when we simplify this equation, divide by 0.7 multiplied by 1000 multiplied by 9.81. Okay, let me use a calculator. 3501 divided by 0.7 multiplied by 1000 multiplied by 9 9.81. Okay, I find here to be 0.51 approximately 0.51. Okay, basically it is 0.509, so I round off meters, which is equal to 51 centimeter, right? There we go, we found the head at A. Now we have to find the head at B. Okay, let me use that space. Okay, now we are going to find the pressure head at B. First we will find the pressure at B, then we will convert it into the head, right? So the pressure at B is what? We know pressure at B is rho G H2, right? At B will be due to the water, H2 plus. Now we are finding pressure at B. We find rho G H2 is up to this. Now at this point is A, so we have to add this head pressure 2, and we already know the pressure at A is this, right? This is pressure at A plus, let me first just write pressure at A. So pressure at B is going to be is equal to rho, it is water at here, right? Which is density, whose density is 1000 kg per meter cube multiplied by 9.81 multiplied by H2. H2 is 4, right? Plus pressure at A 3501. Okay, so what we get pressure at B equal to, let me use the calculator, Newton per meter square. Okay, so here we go, we find the pressure at B. Now we know pressure at B, which is equal to rho G head at B, right? Because that is the formula. Okay, so this is going to be Now at B, what is it? It is water. So the density is 1000 multiplied by 9.81 multiplied by HB. Okay, it is equal to 42741. Okay, from here we can find the head at B is equal to 42741 divided by 1000 into 9.81. This is what I found, 4.36 meters. Okay, now we found the pressure head at B2. Now we have the pressure at C. Let me use here pressure head at C. Now first let's find pressure at B, pressure at C, which is equal to pressure at B, right, because B is above it, plus rho G H3 plus rho G H3. Okay, see how I find. We have to find the pressure at C, so which is the height of water above it, right, above it. Now the height of it is not the water, basically it is the something unknown fluid whose specific gravity is 1.6. okay, whatever it is, the height, we have to find the pressure at C. It is the high, it is due to the height of this fluid up to this B point. Why we don't consider up A or up to this top? Because we don't have to, we just have to find the pressure at C due to the height up to B, right? Why? Because at B we already know the pressure, right? So we will find pressure at C up to 2 meters, right? Up to 2 meters we go up and we reach 2 meters, and here we find B, right? We encounter B, so we add this pressure too, so we get also the pressure at C due to all these heights, because when we add pressure at B, because pressure at B is due to all this pressure at B due to A and due to this and due to air. Okay, in this way we find the pressure at C. Okay, now the height here is 2 meters and the specific gravity of this unknown fluid is 1.6. okay, and how much is the pressure at B? We calculated. Okay, here it is. This is the pressure at B, right? 42741, right? So we are going to use this 42741 plus rho. Now this is unknown material, 1.6 is the specific gravity, so this will be G density of water GH3. Oh, and this is going to be 42741 plus G is 1.6 multiplied by 1000 multiplied by 9.81 multiplied by H3. How much is H3? 2 meters. 2, right? So this is going to be the pressure at C. Let me use the calculator. This is going to be 74133 Newton per meter square. So we find the pressure at C to be this, right? This is the pressure at C. Now pressure at C we know, let me use this space. We know pressure at C is equal to rho G HC. Okay, now let's put the values. The values are, how much is the pressure at C is this 74133 is equal to, now this density is, it is an unknown fluid, G times density of water multiplied by G multiplied by HC. Now what is the specific gravity of this fluid, unknown fluid? 1.6. This is going to be 1.6 multiplied by 1000 multiplied by 9.81 multiplied by Hg, right? 74133. Now here from this equation we are going to find head at C, which is going to be equal 74133 whole divided by 1.6 multiplied by 1000 multiplied by 9.81. Okay, I found head at C to be 4.7 meters. Okay, therefore we find the head at C. In this way we found the head at B, we found the head at A, and here we found the head at C, right? That's, I think that was all asked in the problem. Find pressure heads at A, B, and C, and we found it. Now if you want the notes, these problems on a note, no problem, I will provide the PDF notes, okay, in the description or in the comments. Okay, you will find the notes right here. Also, if you have any problem, please ask me. Okay, ask me, I will make a video on them and I can help you in any of the problems. Just ask me in my email or comments somewhere and I will provide the solutions. So that's it for today. Thank you and see you in the next class.